How's everybody doing? Say hi in the chat if you're here and you want to say hi. Navik, Jax, good to see you both. Jared, good to see you. Looks like our class is starting to get into our old habit of showing up a couple minutes after 10 o'clock. At least we don't have that door to deal with anymore. All right, in the comments, anybody missed the door? Well, we can't wait for everybody. So if you're prepared with your coffee, join me in the simultaneous sip. And throw some sips in the chat if you just joined in. Abby, I agree. The door was worth the quarantine. I'm going to be honest. I don't know if that's true. All right, so we left us with quite the cliffhanger yesterday, and that's what we'll start with today. Let's compute the limit as x goes to infinity. The square root of x squared plus 1 minus x. Okay, and we ended class by saying a good strategy for how to solve this, right? Because we could just try to plug in a large number, whatever that means, and you'd get like infinity minus infinity, which doesn't tell us anything. That's like having 0 over 0. It just is. It means we have more work to do. So let's multiply by the conjugate and see what we get. Okay, and now I'm going to write this out, but my question to you is, what's our next step after we simplify this? Where do we go from here? So it'd be x squared plus 1 minus x squared in the numerator, and the square root of x squared plus 1 plus x in the denominator. Where do we go from here? Do we have any ideas? Yeah, so Jax, you're on the right idea. Would you divide the fraction by the square root of x squared? Yeah, Max is also on the right track. In this case, we could just plug in a large number and say we get 1 over a really large number, but let's talk about how it's going to work. Yeah, so Max, you're right. It would go to 0. But what if we had like some more complicated function up top, which we'll see in an example later today. So in this case, we want to multiply the numerator and denominator by the highest power, 1 over x to the highest power that appears in the denominator. And you may think the highest power is x squared. But that x squared is inside of a square root. So really, that's just an x to the first. Okay, and so the highest power of x that appears in the denominator is x to the first. So we could do this. And yeah, so what Max wrote in the chat is correct. But this method will work when we have even harder examples. So we could finish it here and say 1 over infinity, that's going to go to 0. But in this case, the limit as x goes to infinity of 1 over x in the numerator, and our denominator becomes the square root of x squared plus 1 over x plus 1. Okay, and now since x is positive, x is equal to what? So x is positive because we're going to positive infinity. So this is what we had written in, I forget, maybe we wrote it in red yesterday. Well, since x is positive, x is equal to, yes, Rena, exactly right, the square root of x squared. If x was negative, we'd have a negative here. And so we could rewrite this as the limit as x goes to infinity of 1 over x square root of x squared plus 1 over x squared plus 1. And now I'll just finish it off for us. Okay, I know we could have finished this a couple of steps ago, but it's good to work it out the long way sometimes. The numerator becomes 0, and the denominator becomes 2. So this whole thing is 0. Okay, and so before we move on, and we'll do another example similar to this in, I don't know, 20 minutes or so. But before we move on, are there any questions on this question at all, or maybe something we did yesterday? And feel free to say no in the chat, just so I know you're hearing me. Okay, good. So it seems like a few of you are following along. That's great. Yeah, so now the next question is evaluate the limit as x goes to infinity of sine of 1 over x. Okay, and feel free to put your guess. You don't have to explain your answer. I'll do the explaining for you. But put your guess in the chat if you have a guess. Yeah, a few of you are getting it. It's 0, and so let's just figure out why that's the case. So sine is a continuous function. It behaves nicely with a limit. So basically what we want to do is just, this is equal to, well, we know this goes to, so we know the limit as x goes to infinity of 1 over x equals 0. So the limit as x goes to infinity of sine of 1 over x is equal to sine of 0, which is 0. Okay, so this theorem that we had yesterday about what happens to 1 over x as x gets really large, it works well with the trig functions as well. Okay. So it's not always the case that our limits are going to converge to some number. It could go off, we could have a limit go off to infinity, or it could go down to negative infinity. So let's discuss what that means and maybe sketch a few pictures, and then we could look at some examples. So the notation, the limit as x goes to infinity of f of x equals infinity. What this means, or this is used to indicate that the values of f of x become large as x becomes large. Okay, so for instance, if our function did something like this. So this is an example as the limit as x goes to infinity of f of x equals infinity. So what I want you to try right now is make a sketch of functions that satisfy, well, this one will be the limit as x goes to infinity of f of x equals minus infinity. So what does that look like? This bottom left, I want you to draw the limit as x goes to negative infinity of f of x equals infinity. And then this last one, the limit as x goes to negative infinity of f of x equals negative infinity. So I'll give you a minute to try to work these out. So just in the chat, because you're not going to be able to answer this in the chat. I want to know: are you all just working by yourselves, or have any of you, phoned a friend during these live streams, or yeah, how are you all doing these live streams? Just sitting by yourself at home, or what's your setup like? I'd like to know. Oh, Ellie and Ren are FaceTiming. That's a great idea. Jared is lonely. Max working alone. It's sad. If you have any siblings, they're free to stop by. In my linear class, one of my students' little sisters is sitting in on linear now. Not sure if she understands any of it though. Oh, I didn't mean to ask such a depressing question. Yeah, but the FaceTime thing I think is a good option if you have that technology. Okay, so I'm going to just fill in the blanks. So what does it mean for the limit as x goes to infinity of f of x to equal negative infinity? It means it tails downwards as x gets large. Okay, so it doesn't have a horizontal asymptote, for instance. And then similarly, as x goes to negative infinity, f of x equals positive infinity. Means we go up this way. And so just in the chat, just are we good with this so far? This idea of limits tending towards infinity or negative infinity? You could do like this emoji. Sorry. Okay. If you can't tell, this isolation thing is driving me nuts. I just here, I don't have a pet or anything. I just talk to the YouTube all day. We'll get through it. All right, so let's look at another example before we'll get to more of a challenging example. So this example says find the limit as x goes to infinity of x squared plus x over 3 minus x. Jax, I love the emoji. Okay, so I'll give you a minute to work this out. And then we'll work on a harder example. And so during the harder example, I'll give you quite a bit of time. But throughout it, I'd like if you ask questions in the chat. Okay. So yeah, we want to find the limit as x goes to infinity of x squared plus x over 3 minus x. And so now the question is, like if we just tried to plug in infinity, what would happen? We would have infinity over negative infinity, which doesn't tell us anything. Okay, so we're going to have to do a little bit of work. But the process, these first few steps are always going to be the same. We're going to multiply the numerator and denominator by 1 over x raised to the highest power that appears in the denominator. Okay, so what do we multiply by 1 over x raised to what power? Yeah, Max and Jared, you're right. To the first, we look for the highest power of x in the denominator, which is 1. So I know there's an x squared in the numerator, but we care about the denominator. Okay, so 1 over x, 1 over x. And let's see what happens. So this is equal to the limit as x goes to infinity of x plus 1, 3 over x minus 1. Okay, and so what do we get? What do we get now? So what will this what does this limit evaluate to? Positive or negative infinity, I guess is what I'm asking. Right? Because we're going to have an infinity in the numerator, and we're not going to have infinity in the denominator. So will this be plus or minus infinity? Yep, Jax, you're right. Negative infinity. The denominator is going to go to -1. The numerator is going to be a very large positive number. So this would be infinity over -1. The notation is a little bit. It stinks that this is going to be posted to the internet and saved forever, but it gets the point across. It's a very large positive number divided by a negative number. So it's negative infinity. Okay, so if we were to try to plot this, and eventually, actually starting tomorrow, we're going to talk about how to actually graph this function. We know at the end, maybe it has some local maxes and local mins along the way, but in the end, it's going to be going down in that direction. As x gets large, its y value is going to go off to negative infinity. Any questions? Or can we move on to a challenge question? So the question is going to be find all horizontal asymptotes of some function. So how do we find the horizontal asymptotes? That's my question. So if you have an answer, feel free to type that in, and I'll get to writing the actual question. So the question is find all horizontal asymptotes of the function f of x equals the square root of x squared plus 3x plus 2x. Okay, so what is this really asking us to find? Yeah, exactly. We want to find the limit as x approaches positive infinity, and then we want to find the limit as x approaches negative infinity. So really what this question is asking is find find the limit as x goes to positive infinity of f of x and the limit as x goes to negative infinity of f of x. Okay, and one of these is going to be a lot easier than the other. I'm not going to tell you which one. But one of them it takes almost no calculation. The other one is actually pretty difficult. So I'll give you, let's say, 4 minutes to try to work this out. During that time, I'll be looking at the live chat. So ask any questions in there. If you want, this would be a good time to go, top off your coffee or hit the bathroom or whatever you have to do if you're not sure how to get started. But yeah, so in about 4 minutes, we'll talk about this again. And those of you who are watching on replay, which is nobody right now, you could fast forward 4 minutes and you'll see how to get the answer. I'll just remind you at this point. So I sent out that survey or form yesterday on Canvas. Only about half of you have filled it out so far. Please fill it out. Please try to fill it out today so I could give you the extra credit on the quiz tomorrow. Right? You probably want the extra credit, so just fill it out. Just so I could hear how you're dealing with this online the online situation. And if somebody has the courage to do so, does anybody want to just share which of these limits is the easy one to compute? It's okay if you don't know. That's the confused face emoji, apparently, that I just put in the chat. Okay, I don't know how much time that actually was, but it felt like maybe 3 minutes or 4 minutes. So we could start talking about this. The easy direction is, the easy limit is when x goes to positive infinity, and I'll show you why. That's not always the case, it's just in this case it is. So the limit as x goes to positive infinity of the square root of 4x squared plus 3x plus 2x. Well, we could first start by just trying to plug in a really large number, like plug in infinity. And you get infinity, so a really large number, plus infinity. That's just going to be a really large number. So we get infinity plus infinity, which is infinity. Okay, so if you add together two really large positive numbers, you get a very large positive number. Okay? So now the question is, how do we compute the other limit? So how do we start this question? Right, we could try just plugging in a large negative number. We'd get infinity minus infinity, which tells us nothing. So how do we deal with this type of question? Yeah, we multiply by the conjugate, right? This is just like the question we started class with today. So we have the square root of 4x squared plus 3x plus 2x. Let's just multiply by the conjugate. Okay, in our numerator, becomes 4x squared plus 3x minus 4x squared. And our denominator is so this becomes the limit as x goes to negative infinity of 3x over the square root of 4x squared plus 3x minus 2x. Okay, and so now the question is, where do we go from here? Well, just like the question we started with. Yeah, Addie, that's exactly right. Just like the question we started with at the beginning of today's, or almost all of these questions, we multiply the numerator and denominator by 1 over x to the highest power that appears in the denominator. And now again, you're probably thinking that it's x squared, but it's still inside of the square root. So the square root of x squared is x to the first. So we have this. So this works out to be the limit as x goes to negative infinity. Our numerator is just 3. Our denominator is the square root of 4x squared plus 3x all over x, and then minus 2. Okay, and now since x is a negative, we could rewrite x as what? So we could rewrite this x as what? we could rewrite it as negative the square root of x squared. And so now we'll replace this with negative the square root of x squared, and we'll see what we get. Looks like my brother just joined the chat. He would fit in perfectly with this class, showing up 30 minutes late to a 10 o'clock class. At least we don't have that door that squeaks. So our numerator still is 3. Our denominator is the square root of 4x squared plus 3x over x squared. And now notice I forgot something important. We have a negative. So we have a negative on the outside of the square root now because of this fact, minus 2. It works out to this. And now I'm going to finish it up. So if you have any questions on what we did so far, type them in now because there is that 30-second delay. So now we evaluate the limit as x goes to negative infinity. This term goes to 0. We're left with 3 over negative square root of 4 minus 2, which is equal to negative 3/4. Okay, so to answer the question says find all horizontal asymptotes. The answer is y equals negative 3/4. And so what this graph would look like, I'm not sure what's going to happen in the middle, but we figured out the end behavior. When we go to positive infinity, it goes off in this direction. And towards negative infinity, it goes along this asymptote. Okay, and so this type of question, it would be good to know for the quiz tomorrow. Being able to find horizontal asymptotes. And so take a look at that video I sent you, and also the WebAssign practice problems. Okay, so are there any questions on this question or any questions in general? Or can we move on to one more example? So just either comment, move on, or comment with your question. Okay, a few of you are saying move on. So let me erase this. Okay, so the question is, so again, we're just going to evaluate some limit. Or actually, let's treat them as horizontal asymptotes. Okay, let's word this differently. Find the end behavior. So find the end behavior of the function f of x equals x squared minus x. Okay, so again, this is asking us to find the limit as x goes to positive infinity and the limit as x goes to negative infinity. And so this is tricky because, well, we don't really have there's no conjugate here. There's no square root. How do you deal with this? We'll have to come up with a new technique, something that we haven't tried yet. Okay, does anybody have any ideas of how we could do this? If not, I'll just solve this problem for you. Yeah, what Jack said is right. So in general, what we would try to do first, we could just try to plug in infinity and see if we have any luck here. So we want to do the limit as x goes to infinity of x squared minus x. But again, we get infinity minus infinity. So we don't know what that means. But what we could do is we could factor our function. And so we have it as a product of a bunch of terms. Okay, so we have the limit as x goes to infinity of x squared minus x is equal to the limit as x goes to infinity of x times x minus 1. Right, so now it's really easy to evaluate this limit. That's going to be infinity times infinity. If you multiply two really big numbers together, you get a really big number. So this is equal to infinity times infinity, which is equal to infinity. Okay, so our function, x squared minus x, goes off to positive infinity as x goes to infinity. And now we can check the same thing, the limit as x goes to negative infinity. And again, we could use this factored form. Well, that's going to be negative infinity times negative infinity. A negative times a negative is a positive. So we get positive infinity. So what our graph looks like, or the end behavior at least, is in one direction it goes off this way, in the other direction it goes off that way. And what our function is, it's a parabola. So right, parabolas, their end behaviors are always the same, which you learned in high school. So that should pass the logic test. Okay, before I let you go, we're done with this section. Tomorrow we'll start 5.5 and 5.6. They're basically the same section. And in that section, I'll send you the video tonight. This is the section where I tried to make a viral YouTube video last semester. So I really want you all to watch it. I don't expect it to go viral, but you gotta watch it. So just in the chat, has anybody seen the video yet? And if not, brace yourself. But ooh, um, but that's all I got for today. So I'll hang out here for a couple more minutes answering questions. Um, but but yeah, so we're done with 5.4. Tomorrow we'll do 5.5 or start 5.5 and 5.6. And that will be the last material before the exam next week. So if anybody has any questions, I'll just be hanging out here. But if not, just make sure you hit the like button on your way out. You know, it helps the channel. We'll get to our goal of 1,000 subscribers. I have office hours in 15 minutes. That's on Zoom. So feel free to stop by if you have any questions you want to ask. Yep. See you tomorrow, James. Nicole, no, 3.4. I'll check. I'll change the web assign. So up to 3.4 will be due Tuesday. But I'll move 3.5. But you should try to do 3.5 and 3.6 before the test because that will be on the test. Okay, well, I'm going to sign off now. I'll see you all tomorrow. Bye-bye.